Number 2. The two gases in the figure below are simultaneously injected into opposite ends of the tube. At which point should they just begin to mix? And so we have 3 points, A, B, or C. Where are they actually going to come into contact with one another? Now again, this is referring to Graham's law. So we need to remember that all gases at the same temperature have the same average kinetic energy. Therefore, heavier molecules have slower average speeds. Lighter molecules have higher average speeds. And so what we have to do is figure out which one of these two gases has a larger molar mass. And we'll be able to figure out, because it has a larger molar mass, it's going to move more slowly. And so it's going to cover less area, less distance than the other gas. So looking at the periodic table, sulfur dioxide, my calculator over here, sulfur dioxide, it's going to be a 32.01. That's sulfur, mass of 1 sulfur plus 2 oxygens. This has a mass of 64.01 grams per mole. Ooh, I think this one's going to be the lighter one. The mass of 1 sulfur plus the mass of 2 hydrogens, 34.03 grams per mole. And so we see that H2S, dihydrogen sulfide, sorry, we just call it hydrogen sulfide. Hydrogen sulfide is going to move faster than sulfur dioxide because sulfur dioxide is heavier. And so it's going to be moving for the same amount of time, but because it's going slower, the distance is going to be less. And so out of these 3 spots, because this H2S is going to move faster, it's going to spend more, it's going to cover more distance in the same amount of time. I would assume that it's going to get to portion C by the time this other gas gets to point C.